Now this is a quite easy problem, and this says find the electric field strength at the center of a hemisphere of radius r, uniformly charged with charge density, surface charge density sigma. So sigma is the surface charge density that is also given to you. So this is uniformly charged with sigma, that is surface charge density. And let us say r is the radius of this hemisphere. And radius of hemisphere is also given to you, so radius is given. So how will you proceed for finding electric field at point O? So let us say this point is O, center of hemisphere. So what we can do is, we can do ring summation. So let us say I have an angle theta. So from here, if I consider an angle theta, so this angle is theta, and let us say there is a ring. Now at d theta, I have another ring. So if I cut two rings at theta and d theta, I will have this ring. Are you getting? So it will contain some charge, and due to this ring, so let us say this distance is x, and basically x you can find. So this triangle, this is r, this angle is theta. So if I drop a perpendicular from here, so this length will be r sine theta, and this length will be r cos theta. Are you getting? So this is r, so this is r cos theta, and this is r sine theta. So x is basically perpendicular length from the ring to the plane. This is r sine theta. Are you getting? Now I know, so this is my ring. So basically we know if I have a ring, due to ring the electric field at center at a distance x is given by q into x. This result we have already derived, qx by 4 pi epsilon naught a square plus x square raised to the power 3 by 2. A is the radius of ring and x is the distance. So if I apply the same thing, what is the charge on this ring? So let us say this length is, we have already calculated, this is r, so this is r cos theta. This is the same length. So what is the perimeter of this ring? This is 2 pi r, but r is r cos theta. So the area of this ring will be 2 pi r, r cos theta. This is the perimeter, into thickness is r d theta. Are you getting or not? So this thickness is r d theta. So this is r and this angle is d theta. So this becomes r d theta. So this is the area of elemental ring. If I multiply by sigma, so this will give me q. What is x? That is this perpendicular distance, that is r sine theta. R sine theta. And this divided by 4 pi epsilon naught a square plus x square, that is the radius whole square plus distance whole square raised to the power 3 by 2. So this distance is r sine theta. So I will have here r radius of this ring, radius of ring is r cos theta. So r square cos square theta. So this is the radius of ring. And the height, that is this x height, r sine theta. So we will have r square sine square theta raised to the power 3 by 2. So if I do calculation, so we will have 2 pi, 4 pi goes, so I will have 1 by 2 epsilon naught. So let us plug this value. 1 by 2 epsilon r into r square, I will have r, so r cube. And this r square cos square theta sin square theta 1. So this is r to the power 3 by 2, simply r cube. And what I will have? I will have sigma into sin theta cos theta d theta. Sin theta cos theta d theta. Are you getting? So if I see, I can write this is equals to sigma by 2 epsilon naught. Are you getting? So this is sigma by 2 epsilon naught, RQ cancels out, sin theta cos theta d theta. And what should be the integration limit? So integration limit should be, so if you take 0, you will have here, you will have a ring. So if you increase, you will have a ring something like this. So slowly radius of ring decreases. When you have pi by 2, you will have this point. You're getting? So integration limit will go from 0 to pi by 2. I think all of you can understand this one. We have already discussed these things in the class in details. Now I can write sin theta cos theta is sin 2 theta by 2. So this will become sigma by 4 epsilon naught. This is sin 2 theta d theta 0 to pi by 2. Now if you do this integration, I think you can do this one. So let us do this integration and give me the final answer. So if you do this integration, this will come out to be 1. This is your task. You have to perform this integration. So final electric field will be sigma by 4 epsilon naught. Are you getting? Now the same question also says calculate the potential at the center of a sphere. So for calculation of potential, we will proceed the same thing. Only thing will be, so potential is given by Q by 4 pi epsilon naught R due to the point charge and even due to the ring. So due to the ring, if you remember, the potential is also given by 4 pi Q by 4 pi epsilon naught R. So let us say in this case, so let me describe this one again. So this is my hemisphere. So this is the hemisphere. My target is to calculate potential at this point O. So let us take a ring. So if I consider my ring here, so elemental ring of course. So this is the width. Basically you understand. Now these charges, so charge on this ring, all charge is situated at a distance of R. Either you take this charge, or you take this charge, or you take this charge, or you take that charge. All charges of ring are situated at a distance of R. So this is simply potential due to this ring will be dq by 4 pi epsilon naught R. Because potential are a scalar, so they all are situated at a distance R. So simply, if I sum all the charges, so I will have whatever the charge I have on this will be dq. And now dq I already know, so V is, so we have already calculated dq. So you can check your copy. So dq I have already calculated. So this is 2 pi r cos theta into r d theta into sigma, that is dq. Are you getting or not? So this value 2 pi r cos theta r d theta into sigma. So let me write dq. So copy this one. 2 pi r cos theta into r d theta into sigma. So this will give you the radius, this will give you the thickness, this will give you perimeter, this will give you thickness, this will give you charge density, and the overall divided by 4 pi epsilon naught r. Now if you see, this will be r square and the denominator will have r. So this cancels out. So you will have 2 pi also cancels out. So you will have simply 2 epsilon naught. And in the numerator you will have r into sigma into cos theta d theta. So let us check yourself. Now again integration limit will be 0 to pi by 2. So integration of cos theta is sin theta, and sin theta at pi by 2 is 1 and sin theta at 0 is 0. So this will be, I think you can do this integration, sigma r by 2 epsilon naught. So this is the potential. Now you can remember this result. So if you have a hemisphere, So due to this hemisphere, electric field at this point will be directed along the axis, because I have taken one ring, and due to one ring this is along the x-axis, along the axis of ring, and if I consider all the rings, this will be directed along only along the ring. And the value is, we have calculated the first part, this is sigma y 4 epsilon naught. Are you getting? Now if I find, so this is the electric field, and potential is simply sigma r by 2 epsilon naught. If possible, you just remember these results. And we'll discuss the next problem. So these are quite interesting problem. One important point is how you have to take a ring, elemental ring, and then you have to find the total charge on that elemental ring, and due to that charge you find the electric field. And of course, if I have a ring, I have already an expression for ring. What is the expression? I can use that expression. For potential, I know that the q by 4 pi epsilon r. So at any charge in the ring is always situated at a distance r, because this is a hemisphere. So center of the hemisphere will always have a distance r at any point on the ring I can take. So this is simply dq by 4 pi epsilon r. R is the capital R, radius of the hemisphere. And if I take the dq value and integrate, we will get the same potential. We'll discuss the next problem.